So as you heard, my name is Mark Dalgleish. I've come here all the way from Melbourne, Australia. It's a really long trip, and I really appreciate you all having me here today. The reason I'm here today is I've seen a massive amount of change happen in the world of front end, but particularly around styling. And obviously I've been quite close to this topic. Over the last year, we've seen the rise of CSS Modules, something that I've played a role in. We've also seen inline styles have a controversial return. And we've also seen CSS in JavaScript more broadly. But if I want to talk about these, I really want to set the stage first and tell a bit of the story of where this came from, or at least my own personal journey. If I start at the beginning, it was with this book, Creative HTML Design, in the late 90s. This is where I cut my teeth on web development. And as the summary of Chapter 13 will tell you, at the time, CSS was not quite ready for prime time. But it wasn't long after that we got CSS Zen Garden came out, and I'm sure many of you are familiar with this project. Basically, the idea behind it was that with a solid foundation of semantic markup, you would be able to completely restyle a page just by changing out the CSS. So it had dozens and dozens of different designs. It's still there to this day, and it's highly worth checking out. And this is where I personally really fell in love with CSS, and it proved what CSS was all about. But I think over time what we've come to realize is that there are two very different mindsets when it comes to styling on the web. You've got the world of documents and the world of web apps. Obviously there can be some overlap, but they can be very distinct from each other. Because when you're working in the world of documents, what you want is to think about a global scope of the entire document. You want to be able to restyle every header, every paragraph, every bullet list. But when it comes to complex applications full of nested components, what you really want is to have a higher degree of maintenance, the ability to encapsulate the different sections of your page from each other and style them independently. So to deal with this problem, the fact that CSS is built for documents fundamentally, over the years we've got many approaches like OOCSS, SMAX, BEM, Suit. These are all variations on a theme, all basically trying to bring much needed structure to our CSS. Arguably the most widely used in production is BEM, or Block Element Modifier. I'm sure many of you use it in your own projects. And ultimately it's just a naming convention. You have blocks, the different sections of the page. Within those you've got the different elements and the modifiers, the different states that they can be in. But at the end of the day, it's just a naming convention. It's completely up to you to follow this religiously every day, every time you write a selector. What that would lead to is markup that looked like this. It got quite heavy. You would have a lot of classes in there. And even though a lot of people didn't like that first impression of all these classes, the benefit was really massive here. It meant that you could trace where the styles were coming from. There was some real semantics to these styles. And suddenly our CSS could scale to the size of large applications without becoming really cumbersome. And that kind of leads us to where we are today, this style of thinking. We're well and truly at this point in what I'd call the age of components. It really kind of went mainstream with Backbone as components back in the day, but since then we've got Angular's directives, Ember has a component model, and of course we're getting native web components coming to browsers now, as well as Google's Polymer library, which polyfills the web component spec and adds some extra abilities on top. The one I'm going to focus on today is React for a variety of reasons. The main one being it's what I've been using for the past couple of years, particularly because it allows us to server render our applications while using a component model. I was personally very excited about web components, but that, I have to say, died down quite a bit when I saw that with React we could server render our applications. That's very exciting to me. Now, components are nothing new. They certainly weren't invented on the web. But even since the earliest days of the web, we've had some degree of built-in native components. Arguably now they're showing their age, but we've got things like the select box, the HTML5 input box, input type with here we've got a date selector. And what's great about these is that with a very small amount of markup, you just drop it in your page and you get a wide range of interactivity, styles built in. It's very simple interface for us to deal with. What's worth noting here is that if there are any CSS and images required to render these correctly, they are private to the component. You don't have to think about including a style sheet to make that HTML5 date picker work. It just comes with it built in. We can, of course, override this, but generally, it's something we don't have to think about. Now this, of course, came crashing down the second we used third-party components. So if you take the canonical example of the jQuery UI date picker, probably the most widely used third-party component on the web, when you download this bundle, the zip bundle from their website, what you would find inside is a variety of different asset types, lots and lots of files. You'd have lots of images, CSS, JavaScript, not to mention the custom HTML you'd have to include in your page to make it work. And our tools have reflected this mindset for a long time. Even to this day, a lot of us are still working this way. If you look at a tool like Gulp, the streaming build system, the average Gulp file resembles something like this. You would have a section for your JavaScript, a section for your CSS, for your images, and so on. Notably, it's treating all your asset types completely in isolation. They don't know about each other. The relationships between these asset types are completely in your head as a developer. You have to maintain that. If you drill down into just one of these in particular, we look at Sass. Sass, of course, compiles our CSS. But because all it knows about is our CSS, it basically leads to something like this, an index.scss file, where it's just a wall of imports informing Sass where the rest of our styles are, telling it how to traverse all the CSS in our system. So when we think about components and the fact that with components, you want all these assets to be co-located, to be related to each other in the way that native components in the web, the way that they work. How should tooling work in the component age? And I think we've got a really, really good example in the form of Webpack, arguably the de facto standard in the React community, and for really good reason. It fits the component model beautifully. And the reason for that is it supercharges the require statement in common JS modules. So here we've got an example of a very simple React component where you'll see in the markup it's using some CSS classes. But of course, for that to work correctly in our application, it depends on the CSS being present. So with Webpack, what we're able to do in that first line is actually explicitly require the CSS needed to render this component correctly. So whereas previously you would have a big global ball of CSS and everything just kind of assumed that the right classes were in that style sheet, here the relationship is very explicit. And that CSS will only be included in your bundle if it's actually required. So you get kind of dead code elimination in your CSS for free. And what's great about this is that you maintain that simple interface that we come to expect from the native components. Because now what we can do is we can import the component and we can render it. And the fact that internally it uses CSS and that CSS may in turn require some images, we can remain blissfully unaware of that as a consumer of this component, which is really great for maintenance. Now, I work for a company in Melbourne called Seek, and Seek is the #1 job site in Australia. It's a household name. If you want to find a job in Australia, this is where most people go. And we were really excited about using React because, as I said, we wanted to build progressive single-page apps. We want all the richness of a single-page app, but what we want to be able to do is server render that initial view so that we get the SEO benefits, we get the performance benefits. It feels like we're not breaking the web. Whereas with typical single-page apps, with web components, with the way our Angular apps had worked, the first thing you would see rendered was a loading indicator while we made an AJAX request. I'm sure many of your sites work the same way. But React allowed us to move beyond that into the world of progressive single-page apps. So for that, from a styling perspective, what we needed was server-rendered CSS, as any sort of static or server-rendered app would work. We need pseudo classes like visited, before, hover, focus, and so on. We need support for media queries because we were going for a highly responsive site while we were at it. We needed CSS animations. We wanted to go heavy on animations. As we heard yesterday, the importance of animations. We're big fans of that. The other thing to note as well as far as pseudo classes is that we wanted to use them for non-JavaScript interactions to increase the interactivity of the page before the JavaScript loads. We do assume that our clients have JavaScript running, but there's a period of time where the JavaScript hasn't loaded yet, and we want the site to remain interactive at that point. So how do pseudo classes help us with that? Well, I've got a little example here. Now we've got this little capsule sitting here on this dark planet. And if I click it, what you'll see is as it launches up, we've got an animation running here with a few different layers, things running at different speeds. Arguably not terribly exciting, but what makes this interesting is all of that was driven off a checkbox. There was no JavaScript involved in that at all. So I can go and I can uncheck this, and you'll see it reverse. So again, no JavaScript required for this. How does that work? Well, here's a more realistic example. I don't think many of us want to have launching rockets on our website. Here's a menu that slides out from the side of the screen. So we've got what's probably a div. It's always a div, and it's transformed 100% in the x direction, x-axis off to the left of the screen. And what we've got is a sibling checkbox sitting next to it, and it would probably have a matching label that's styled to look like some kind of menu button. And when you click on that checkbox, what we're going to do is we're going to remove the transform, and that transition will kick in, and that panel will slide out from the side of the screen. So again, no JavaScript required. It means that while the page is still loading, your users can still actually get to the menu, which is probably full of links. Links don't require JavaScript. You can click those links. You can still navigate your way around. That's a really important technique for us. So anyway, if we go back to the start of our journey with React, this was around late 2014 that we got started, and it was around this time that a really important talk from Christopher Shadow from Facebook, really important contributor to the React community, he had a presentation talking about the problems with CSS at scale. And he said, CSS has fundamental flaws at scale that can be solved by writing styles in JavaScript. It's a very controversial topic. This is the slide that got the most attention, and it ran through the 7 problems that they found with CSS at scale at Facebook. And I'm sure many of us would relate to a lot of these issues. Global namespace, number 1, being probably the biggest one that we deal with. As a result of this, a Cambrian explosion of solutions were created. There's a really great project by Michele Bertoli called CSS and JS. It's up on GitHub. And it's basically a README that looks like this. This is just the top of a very large table. And it runs through all the different tools that people have written to tackle this problem and the features of each one. But it really goes to show you how much people got excited about solving these problems. The first one that really caught my attention was called React Style by Andre Pop. And what it did was basically let you programmatically in JavaScript, in the same file as your JavaScript component, you could programmatically build up a style sheet in JavaScript and then attach it as inline styles to your markup. And this is where the controversy started, because I'm sure a lot of us, myself included, grew up in a world where inline styles were taboo. You would never do inline styles. But suddenly what we had here was a way of co-locating our styles with the component, scoping them down, and giving us a way to think about styles being tightly coupled to that component so we could scale up from there. But there were some serious drawbacks with this approach, some real trade-offs. There was no media query support, no CSS animations, no pseudo classes. Of course, you could achieve things that are similar in JavaScript. You could listen to the window resizing and then redraw. Animations you could do in JavaScript. Pseudo classes, hover, you could just add a mouse over event and change a style. But ultimately, this stuff all had a JavaScript dependency. If you wanted all of these things to work before the JavaScript ran, as we were trying to achieve, that was a real serious trade-off. And yet, as a team, we would look at this as an approach, and we couldn't help but really want to take the good things from this. We wished we could use this in our project. Obviously, we were prevented from doing it, but we loved the thinking behind this. So what we did is we asked ourselves, how can we embrace the inline mindset in regular CSS? How do we take the benefits of this without breaking the website without JavaScript? And we found our answer in BEM, Block Element Modifier, the approach I was talking about earlier. And the reason for that is really important, that the block in BEM is really the same abstraction as a component. It's the same worldview. It's about carving up your UI into smaller and smaller, more maintainable pieces that you then compose into a full application. So given that a block in BEM is the same really as a component in a component UI model, that led to a very natural rule that we set up for ourselves, which is that we should never use a block outside a component of the same name. So what did that look like in practice? Well, it meant that in our project, for any given CSS file, right next to it you would find the matching JavaScript file. And of course, that would form a natural component boundary. And the great thing about components, of course, is that they scale up really nicely to the size of a full application. And this approach worked really well for us. So if you looked at the file system, of course, you'd find the matching version of this. You'd see instead of a JavaScript folder and a CSS folder and an images folder, which I've definitely done before and scales horribly, this worked much, much better, where you would have a folder for your components. And as we do, we actually nest our component directories. It's not even a flat list of all components. And within each folder, what you would find is the JavaScript, the CSS, the images, any assets needed to render that component in its entirety. If you drill down into the CSS file, of course, using the BEM notation, you would expect to see that if the component was called myComponent, every single class selector in that file would be prefixed with the name of the component. So you could very easily trace where these styles were coming from. And if you happened to see a selector that mentioned another component, you knew that you'd done something wrong. It was a very strict rule for us. And this scaled really, really well for us. We were really excited about this approach that we were using, and I wanted to share it with the world. I wrote this blog post, Block Element Modifying Your JavaScript Components. It got quite a bit of attention, and I felt like this is where we were going to stay for quite a long time, given the constraints we were under. But importantly, meanwhile in the background, some really important developments happened in the Webpack space. A feature called Local Scope, an experimental feature, landed in Webpack's CSS loader. And this was a huge, huge breakthrough, I think, that really led to where we are today in the world of CSS. Because what it did is it meant that instead of having a require call to a CSS file purely as a side effect, you know, that nothing actually changes in the scope of this JavaScript file. All it would do is instruct Webpack to include some CSS in your bundle. Now what you could actually do is import something from the style sheet, import styles from that style sheet. Now if you're anything like me, you'd look at that last line and wonder, well, if I'm importing something from a style sheet like it was a JavaScript file, what am I actually getting from this style sheet? Well, to understand that, you know, to answer that question of what styles evaluates to, first what we want to do is we want to look at the CSS to get a bit of a hint of what's going on here. This is the custom syntax that was introduced in the local scope feature in CSS Loader. You'd put :local brackets, wrap it around the selector. So here we've got a local header class and a local footer class. But what does local mean? How does this all tie together? So to get a better understanding of that, let's jump back to our JavaScript file. Here we're importing styles from a style sheet, and now what you'll see in the markup is instead of magic strings referring to global classes, there's actually a very explicit reference to styles.header, styles.footer. We had to import something that references those classes from the style sheet. So now the relationship that used to be in your head as a developer is now very explicitly in the code, and this was a huge breakthrough. So if you go back to the CSS, you might be wondering, well, :local doesn't work in a browser. What's going on here? Well, when Webpack compiles your CSS, what it would do is it would compile those into globally unique hashes. It's really just implementation detail at runtime what those classes happen to be. But as a developer, you don't really care. So obviously there's a mapping going on here between this header, footer classes and these hashes. So how does that work? Well, now that we have no more naming collisions, what that means is that we can more easily tie these things together in their local scope and not have to worry about a header class being the same as a header class from another file. You're much more freed up to name things only in the local scope. And so now what we have is a mapping between the local name that we've provided and the globally unique hash. Because we have no more naming collisions, what we do need to have is a mapping from the local name to the globally unique hash. So that's what the styles object that you imported was. It was just an object that instructed how to get the real class from the class you used at development time. What's really great about this too is that because the compiler was generating these classes for you, you can actually configure it. So this is what we do in development. We actually programmatically, automatically generate BEM classes in development mode. In production, our classes are actually minified to a 5-character hash, but in development we have BEM classes, and we can very easily debug where these things are coming from. Now at Seek, as I said, we were going all in on React and using BEM to co-locate our styles with our components. And when we caught on to this experimental feature in Webpack, which of course we were using, we couldn't help but try porting our code base in its entirety across. We had a relatively young code base, not a huge amount of CSS yet, and so this was not too difficult for us to port it across. What that led to is all of our CSS in our application basically looked like this. We had a wall of local everywhere, :local, local, local, every single line. Every once in a while, very rarely, you would find an exception. So if you look at that last line, here you have a non-local class, transition active enter. And the reason for that is because we were using React's CSS transition group, and at the time it needed global classes to work. They've since fixed that, so we don't have to do that anymore, but at the time that was a real example of a global class that we needed. And when we looked at that, it kind of led to a natural question. We said, well, what if locally scoped CSS was the default? You know, if you look at all the other module systems we use, if you look at our JavaScript modules, everything is scoped to that module. And if you want to make it global, you have to explicitly put it on window or put it on global object in Node. Otherwise, it's locally scoped to that file. And why is our CSS any different? So what we did is we opened up a new tab in our editor and we experimented. We said, well, what if we could get rid of all of this colon local noise? So that's what we did. We went through and we removed all the colon locals and said, well, what if that was the default way that it worked? We got to the last line and we realized, well, here's an example where we needed a global class. So what we did is we flipped the model around and we said, if you want a global class, you have to explicitly mark it as global using the same syntax. And what we realized is that this is actually a very simple transform going from the format we saw before to this one here. And so what we did is we looked for ways to implement this. We found a great answer in PostCSS. I'm sure many of you are using this. And it's another CSS preprocessor, or as they call it, a post processor. I'm not sure what the difference is, but it's all plugin based. You can write plugins in JavaScript, and that's what we did. We wrote PostCSS local scope, and all it would do is just that simple transform of taking dot class and turning it into colon local dot class, and of course if it saw colon global, it would leave that alone. So we were automating the process of turning what looked like a regular style sheet into a locally scoped Webpack style CSS file. This felt like a massive breakthrough to us because suddenly we had something that was locally scoped by default, much more maintainable than the CSS we'd been doing before, and all of that BEM, you know, manually prefixed noise just went out the window and it looked like regular CSS. I wrote about it in a blog post called The End of Global CSS, and this took off much more than I expected. I'm sure quite a few of you have read this blog post. The most exciting part of this is that Tobias Koppers, also known as Sokra, the creator of Webpack, he reached out to me and I said, I hope it's okay if I integrate your PostCSS local scope module into the CSS loader. Of course, the answer to that was yes, and as a result, an experimental module mode got introduced to CSS Loader. So now you didn't have to manually wire up PostCSS and the local scope; it was just built in. And so that was sort of the beginning of this journey of making it part of Webpack. It was very exciting. One thing I was concerned about, though, was that all of this was quite coupled to Webpack. I'm a big fan of Webpack, but I felt like this idea was bigger than any one tool. I thought this could really change the CSS landscape. And so I spoke to Tobias about this and I asked him, have you thought about writing a standard for CSS modules that others could implement? I mean, the best way for this to thrive is to have other competing implementations in other build tools. So as a result, we got a new organization and a new repo fired up on GitHub called CSS Modules. We had a README describing exactly what CSS modules were. I created the logo first as a joke, but it's stuck around. Everyone seems to love the logo. And now it's available in CSS modules, in CSS Loader, no longer as an experimental feature. It's now a first-class part of CSS Loader using modules mode. And it's very, very popular in that space now. A lot of people are using that. There are some other features in there that we've added. Class composition is a really interesting feature where, you know, styles.header could map to multiple classes, not just one. Because it's just a mapping to a string, that string can have spaces in it. You can have multiple classes. I won't go into that today. The other one is values, shared constants. A lot of people ask for this feature, and we've got that in there. It's really nice. But again, that's probably a topic for another day. A bunch of people jumped in to help out, and if you're interested, please jump in too. It's open source. None of us are paid to do this, so the more help we get, the better. So as I said, we've got this in Webpack, but what's great now is we've got implementations in Browserify, in JSPM, and I think more interestingly for people outside the JavaScript community, there's implementations in PostCSS, and there's even a Babel plugin. And so what these last two allow you to do is actually use it in environments that aren't all JavaScript based. The world doesn't revolve around JavaScript as much as we might think it does. And particularly with the PostCSS implementation, we've seen people use it in a Ruby on Rails project as an example of something I didn't see coming. It's really interesting. Now, if we rewind a little bit and reevaluate that question of why not do our CSS in JavaScript? I mean, some people are religiously, opposed to CSS and JavaScript. We were open to the idea despite the trade-offs. The reason was because of those trade-offs, because there were no media queries, because there were no CSS animations or pseudo classes. So that was obviously a big blocker to us. We want the full feature set of CSS. But what's important to note is that those limitations are limitations of inline styles, not of JavaScript as a language. I saw a really great tweet. It said, CSS in JS, blasphemy. No wonder why Mark Dalgleish got punished. Yeah, I have angered the CSS gods. I apologize. Actually, while I'm looking at Twitter, I did see one question which was, aren't all these problems with local styles already solved with web components? I tried to briefly touch on this. This is a really important question. I can't server render my web components. Until they can do that, I'm going to stick with React. So anyway, back to the topic at hand. So as I was saying, if I jump back, those trade-offs were restrictions of inline styles, but JavaScript as a language isn't about inline styles. CSS in JavaScript isn't restricted to inline styles. We've seen a lot of really interesting work in this space. I won't go into detail of all the different approaches. The one that's really caught my attention is a project called APHRODITE from Khan Academy, and it's written by Jamie Wong and Emily Eisenberg. And what's really great about APHRODITE is it really tackles these trade-offs head-on to try and solve them. Because while it looks very similar to the solutions we've seen before, like React style, the key difference here is that it allows you to generate a style tag, which means you have the full support of all of the CSS features. So here we're styling a field, and while we can set the typical inline style properties we would have done before, margin, we're also styling. We've also created focus styles and a media query, things that you can't do in inline styles. So that's really interesting. And the way it works is then you can take these styles and you can attach them to the class name attributes of your elements. So now you've got CSS and JavaScript, but all of your styles are using the full feature set of CSS. Now, you might wonder, well, why would you bother doing that? I think where it gets really interesting is this. So I've talked about how important it is to server render our applications. What you can do with solutions like this is you can actually server render your CSS as a style tag. Here, what we're doing is we're taking React DOM server and we're rendering our app to a string. And we're also rendering our style sheet to a static string as well. So now we have reference to the HTML and the CSS. And it means that server-side, when we render this page, not only can we render the app in that div ID app, which is the typical way that we do server rendering in React, we've also got a style tag up the top there where we're rendering the content of our CSS. Again, you might be wondering, well, why are we rendering it to a style tag? Well, we heard yesterday about the importance of inlining the critical CSS. Jamie Wong, in the blog post that outlined where APHRODITE kind of came from at Khan Academy, said, we must deliver the absolute minimum amount of CSS necessary by only sending down CSS in use by components in the server-side rendered body. So what a solution like APHRODITE allows you to do now that the styles are being generated in JavaScript is you can actually, basically every time you server render a page, you're starting from a blank style sheet and you're building up every time you render something. You're only adding the styles that are actually being rendered on the current view. And once it renders in the browser, it dynamically updates that style tag, but you get that server-rendered view of the minimum CSS required to render the page. This is a really huge breakthrough, and I think for certain classes of applications, it creates a strong argument for why you would choose to use JavaScript for your styles over CSS. I understand that that's a very controversial thing to say, and not every application needs to work that way. So there's trade-offs in both. But I think what's really great is we're kind of ending up in a place where whether you want to do your styles traditionally via CSS modules or you want to do them with CSS and JavaScript, we're kind of at the point where it's personal preference which one you want to use. So if you want to talk about these things as a whole, these two different approaches, CSS modules or CSS and JavaScript, let's think about what these approaches have in common. What makes them different from what we've seen before? And I think the key difference is something that I like to call first-class styles. Because now styles are actually something that you programmatically create and hand around your application, rather than having relationships between your markup and your CSS, something that you maintain in your head. Because what it means is that you have to locally define your styles and then pass them directly to the elements. It's no longer an implicit relationship, it's very explicit. So whether you're using CSS modules and you're defining a style sheet and then you're importing that style sheet into your component, or whether you're using inline styles or CSS and JavaScript more broadly, what you're doing is you're creating a style sheet and then attaching it to your elements, but it's always by passing a reference down to that element. Now, the theory might seem really nice, but at the end of the day, we've got to move beyond toy applications, and that's what we've been doing at Seek. We've been putting first-class styles via CSS modules into practice for the past year, building a Greenfields React application. And so far, we're at 70 CSS files with 782 rules, with 948 selectors. We've got 2,886 declarations and 211 media queries, which is, I think, the thing I'm probably most proud of. It's a very responsive website. But out of all of that, what is our global CSS footprint? How much CSS is global versus locally scoped? And this is the entirety of our global CSS. It's basically a CSS reset with a couple of our own tweaks on top. But every other CSS rule in our system is locally scoped to a component. And this has been massive for us to be able to maintain our application as it grows over time. The benefits we've seen out of this is massively increased authoring speed. You don't have to think about the global scope as you work, which leads to less fear of change. You know that this file only affects the files that import it, which means that everything's maintainable by default. You write a style sheet, you import it into a component, and you very clearly understand the relationships, and those relationships can be maintained over time. You get faster debugging basically for free because of the fact that we can generate BEM classes automatically in development mode. And I think one thing that I've really appreciated is as our team has grown, we've brought new people on board, the onboarding process is dramatically simpler than other projects I've worked on in the past, where the CSS is often the hardest thing by far to come up to speed to in an existing project. Our CSS was simple at the beginning, it's stayed simple, and everyone who's joined our project has really appreciated that fact. I think what I'm most excited about is the fact that it's allowed us to much more easily extract a style guide from our real-world project. Because if you look at what I was talking about earlier, where for every CSS file, you've got a matching JavaScript file, that's your component. Our app grew small at first, but then, of course, more and more components were created. That formed a natural application boundary, but what we started to find is that as we wanted to spin up more applications on this same stack, a lot of these components were more generic company-wide components and weren't restricted to our one code base. Because all of the related assets to a component were co-located, what we were able to do is spin up a separate style guide and extract the common components into that separate repository. This has been a massive step forward for us, and it's really been made possible because of CSS modules and the component-based first-class style mindset. That, of course, is a topic for another day, and hopefully you'll get to hear more from me about that soon. But ultimately, what this is all about is about making a much more productive development team able to move fast without breaking things, while making your users happy. We can server render our application. We don't give up any of the fundamentals of the web, being able to server render a static set of responsive, highly accessible content, but the development team doesn't have to make any sacrifices to do it. And the final message I want to leave you with is if that you've been skeptical of these approaches, or you haven't known much about them before, or if you've bought into CSS modules but still written off CSS and JavaScript, there's a lot of pros and cons here. There's a lot of really great ideas floating around, and hopefully you've been encouraged to have a go at trying this out in your own projects for the sake of your own, the happiness of yourself and your team members, and ultimately the happiness of our users. That's it for me. Thank you so much for listening.